When poa plants in the field become damaged due to drought or heat or some other effect, there's a lot of fungi that can come in and attack the plants. Let's take a look at one of those other fungi. It's not anthracnose, but it's something that can possibly look the same. Now, if we take some of those samples back from the field, there's a variety of organisms that we find on the samples. There can be anthracnose or some other stress-related organisms. I'm going to show you an organism that can be confused for anthracnose. It's probably not the primary pathogen, or it's like anthracnose. It comes in when the plant is stressed, and we'll describe the details of this organism as we go through a diagnosis. But let's take a look at what you'll see with a hand lens again with this organism. And what we're looking for are some small dots on the foliage. These dots don't look like much in this magnification, but we're going to take a little bit closer look under a dissecting microscope and then a compound scope, and they're a little bit interesting to look at, not quite like anthracnose. Now as we look back at the leaf tissue, what we see when you're scanning around a sample like this one is that the healthy leaves seem to be fine. You don't see a healthy plant that has a lot of damage on it. The plants that are here that you see these dark parathecia, what they called, of this fungus. We'll talk about what it is in a minute. You can see these plants are pretty much dead, and even at the leaf-fired tips, for example, this plant here, which is a typical symptom of firing if you get some drought stress, that the leaf tip itself will be shed by the plant, will be abandoned, so it'll wall it off somewhere down to try to keep some of the leaf. This is dead, and that part of the leaf can be colonized by pretty much any fungus. It doesn't really have the ability to defend itself. And what happens in these cases is some of these plants, like these ones, this one here, has been killed for whatever reason. You can even see that it made some seed, but it has succumbed to the attack of these less pathogenic pathogens. But it was probably already dead. It probably was not killed by the pathogen. It just looks like the pathogen killed it, but really the pathogen came in after the plant was already dead. And under normal conditions, you see over here, this plant's able to survive even though there's a lot of inoculum around. It's healthy enough. So what we're going to do is go ahead and take one of these leaves. In fact, we'll take this one right here and we'll put it on a microscope slide and show you the characteristics of the fungus that looks somewhat similar to anthracnose. Okay, here's what the parathecia look like under a compound microscope, and if you're curious, they are about 50 microns across, the distance of those parathecia. Now what I'm going to do now, and I'll show you these flash-shaped structures, is I'm going to press on the microscope slide with a pair of forceps and see if we can push out the spores and the sac that holds the spores, and we'll discuss that in a second. Let's see if I can get this to work. Here we go. A little bit. There's a little bit of trouble to get those out of there, but here we go. We can see them a little bit now. Let's zoom in. So those are the spores, and there's some broken parathecia, and then we'll show you the details. Here we go. And now we're looking at the spores of the fungus, and they're in a sac. Let me see if I can find a clear one here. Okay, here's a few of the asci, or sacs, that the spores are born in, and those are inside the parathecia, and they're expelled from the parathecia. Well, so that's it for the diagnosis of Leptosphaerulina trifolii, and you can see the sacs that are around the spores, and you have the characteristic types of spores. Probably won't need to really understand this fungus very well because it attacks plants that are pretty much dead anyway. But this is one that can be easily confused with anthracnose. Main thing that you'll see is that this one will not be on green tissue hardly ever. It's mostly attacking more or less senescent or synectotrophic type of a pathogenic state. That's about it for now.